Okay, welcome back to I Don't Know Code. Let's get stuck into day 4. So here we are on day 4. Let me get that up on screen. Day 4, scratch cards. Okay, so the gondola takes you up. Strangely though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colourful square cards. Oh, hello, the elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island Island. After all, I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat. And you can go visit the gardener. I've got all these scratch cards as a gift, but I can't figure out what I've won. Okay, so the elf leads you over to the pile of colourful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has a list of numbers separated by a vertical bar. Yep, the pipe character. A list of winning numbers, and then a list of numbers you have. You organise this information into a table, which is going to be our puzzle input. Okay. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. So these are the winning numbers, so it's like a lottery, and these are the numbers I have. So I'm just checking if any numbers in this set is inside this set. That's it, right? The first match makes the card worth 1 point. Each match after the first doubles the point value of that card. Okay. In the above example, card 1 has 5 winning numbers. 4, 1, 8, yep. And the 8 numbers you have, of the numbers you have, 4 of them are winning numbers. That means card 1 is worth 8 points, 1 for the first match, then doubled 3 times, so it becomes 1, 2, 4, 8, 4 matches. So in this example, it's saying the Pile Scratcher cards is worth 13 points. How many points are they worth in total? And if we have a look at what he thinks the scratch card looks like, yeah. This will be good inspiration for when we come to rendering stuff. Okay. So let's get stuck into coding it up. So we'll go ahead and create day04.zig. I've made this day template that I can just copy and paste to get us up running pretty quickly. Then we need to go into our main zig. We need to import day4. And then we need to process day4 and append it to our array of days. Okie dokie. So, and then I'm going to go ahead and get our test input. Not this one. It is. This is our test input. And our expected value is 13. I'm just going to put that as a comment. So we're going to load our test data. As usual, we're using a line iterator. So let's go ahead and put this test in the corner so I can see it. So we just want a list of the winning numbers and a list of the R numbers. So that's pretty easy. So each card is going to be a struct. It's going to have an ID. Let's do usize. It's going to have a list of numbers. So let's create our usual number array. It's going to be a banded array of type. These are all unsigned, so I'll do like E32. 50 for now, and so we will have our winning numbers. That's going to be our number array, and played numbers. Okay, and then we'll have a function to init this. It will return a card. We'll pass in the ID. There we go, so that's initialized. So we'll create our card. This will be card, we're going to try card init card ID. Card ID plus equals 1. Actually, no, we can read the ID from this, can't we? So this is how this works. So we'll do parser read. Is it skip word? That's it. So we expect the word card in the space. And then we're going to do parse. I think these all need a try because they can fail, yeah. And then the card ID is going to be try parser read number, and we're going to read a usize. And then we'll do try parser skip char. We expect to chip this. A try parser skip whitespace. Yeah. And then we're going to keep reading characters, keep reading numbers until we reach the pipe. So it'll be something like while true, try parser read number E32. Try parser skip whitespace, and then what we'll do is parser peak char does not equal the pipe character. There we go. card dot winning numbers append, and we'll append the number. Okay, so there's your card ID, and then we'll do try. We'll need to skip white space, and then we need to do the same again until we get to the end of the line. So while parser is we're not at the end, we'll do this. We need to skip white space. This could fail because at the end there is no white space, so we'll just do catch and do nothing. And then we'll do try card dot played numbers append number. Our solution will have cards. So let's just say right now there's only 6, I think that's 10. We'll say cards is equal to a card array. So we're going to put this in the solution. So I'm going to create the solution up front, and then we'll do try solution cards append, and we'll append the card. Cool. We are doing a bit of copying of data around, but that's fine. And then we just need to draw the card. So we'll do for self.cards.contslice card. I want to do relib draw text. Or is it relib draw text alloc print? Yeah. So we'll pass in our allocator. It's going to be card D. Args are going to be card.id. I'm going to draw that 10, 10, 10, c.white. And then we'll do for card.winningnumbers.contslice number. D number 10. I'll do that at 20. We want an index, so this would be const xpos, which is usize is equal to I times 25 plus 10. Well, there we go, xpos. And then we'll do the same for R. This will be Y equals Y times, let's say 80 plus 10. These all go Y pos. Oh, sorry. Winning number. So this is the played numbers. Okay. Will that run? Oh, this needs to be a character, not a string. I do need to intcast these. So that needs to be intcast to a cint. Okay. Error invalid skip white space. I think, do we also need to do this here? So it's an optional skip white space. Invalid skip white space. So where's... Oh, so if we peek that, then we need to skip that, right? And skip white space after it. Okay, and so now we're drawing our 6 cards, 1, 2, 3, 4, 5, 6, and we have successfully got the right data in them. Which is nice. A little bit small at the moment, so I'm going to double the font size. So I will do this here. I'll just do the usual const font size. I'm going to make that 20. These are getting a bit long, so now I'm gonna put these on new lines. So this becomes font size. We want to add font size to that. Same with this. This becomes font size times 2. This will be times 3 plus 10. Cool. I need more spacing between. I forgot to put font size there. We'll just do that. I'm going to set that to 4. I want more spacing between the numbers. There we go. That looks a bit more readable and nicer. So now we just need to go through each of these numbers and make sure if any of the sets match. And we can do that in a pretty naive way, where we'll just loop over each of these, and then for each of these we'll loop over each of these and see if the set is valid. Once we've looked into that, we can remove a number from this set. Another thing we could do is we could, if we look at our actual puzzle input, the numbers don't go up that high, and they never repeat because it's a scratch card. That's how they're designed. So we could do this as just an array of a sparse array of booleans, say up to 100. So it would actually look like this. We would do winning numbers is going to be 100 bool equals undefined. Make that undefined by default, so it wouldn't be a number array. The plate numbers would still be an array, but then this would just be standard.mem.zeros. and then instead of adding winning numbers, we would say card winning numbers number equals true. Right. And then instead of looping over this, we'd loop over card.winning numbers. I think we can just do that. We wouldn't have I anymore. Instead, we'd have a this. And I'll just do, okay, if not is winning, we continue. Otherwise, this becomes winning num I. Winning num I, we add 1 to it. Actually, yeah, we do want this. This just becomes the number. I'll call this X index. There we go. Does that still work? Okay, it still works, and it's actually sorted it from lowest to highest, which is interesting. And so the nice thing now is there's our winning numbers, played numbers, and we can do matched numbers. This can be another bool array. I'm actually gonna put this here, and then const equals 100. There we go. So this passes the input, and then we can sort of check each card. So for solution.cards.const slice, well, we'll do cards dot get the card. This will be a plate number, and then we just say card dot match numbers played number is equal to played number So if the played number is a winning number, we'll set the match number to also be true. I think we want this to be a mutable pointer to the card, so we can mutate it. I think that's right. So let's get the color. So the const color will say if card matched c.green there you go, so you can see 17 matches for 17. And we can actually do the exact same thing with the played numbers, right? And let's just double check that all matches up. So oh, I'm looking at the wrong example. So card 1 has 5 winning numbers. Yep. Card 2 has 2 winning numbers, 32 and 61, 1 and 21, 84. Cool. Starts off for each so we'll say isMatch equals this. And each match doubles the number. So we'll say var score equals 0 for this card. If isMatch, so if it is a match, and if score is equal to 0, then score is equal to 1. Else we'll just do score times equals 2. Then once we've done that, we'll just say solution answer plus equals score. And these are I32, not U size. There we go. So the answer is 13, which is what we were expecting. So now we can go ahead. I think I've got day 4 puzzle input, my actual input here. Very good. This has a lot more cards. We got 211. So if I go ahead and put in day 4. I'm gonna do our usual offset, so Let's do raylib begin offset 2D. I'm going to offset by 200, 0. I'm going to defer raylib end offset 2D. We're going to be using DT because our solution will start off with a time, which is just going to be f32, starting off at 0, 0. We will say self.time plus equals dt. So, and this is just going to be negative self.time. So it's going to be scrolling up. Our card array now needs, let's put in 256. Our number array, I think it's still 50 is fine. Oh yeah, this is const. So we'll put this up here, so this will be our time. There we go. Okay, so we're getting invalid character somewhere in here. Let me just make sure I've definitely got the right. So I'm going to copy all that, I'm going to delete all that, paste. Invalid character. Oh, is that in our parse number? When we parse int, this can return invalid character. Interesting. Ah, because our numbers can be much bigger, I was only skipping, so I need to put some skip white space in here. So I'll leave the white space out. There we go. Cool. I like this to scroll, unless it's just the frame rate. I don't think it is. It might be. Because if we just do the buffer from 0 to, I don't know, 20. I would like to see the score as well, so I might actually put that in the card. So I'll put the score here, which will be an I32. which is 0 by default. And then we won't need that anymore. We'll just say, okay, if card.score, 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 and then here we'll say card score percentage D. And then for these ones, font size small, I'm going to make that. Font size. Oh yeah. Just trying to get the layout correct. There we go. And then I want this to scroll much faster, so this will be, I don't know, times, can I do it like 40 times faster? Cool. Do like 100. How slow would it be if I just did that? There we go. And then this rollup answer, I want to draw here, I guess. So we're getting 2667. Is that our answer for day 4, part 1? Yep, 2667. Cool. So we've done part 1. We can now move on to part 2. So part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card, equal to the number of matches. So if card 10 were to have 5 matching numbers, you would win 1 copy of each card's 11, 12, 13, 14 and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. Okay. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Okay. You win copies of scratch cards below the winning card equal to the number of matches. Gotcha. So card 1 has 4 matching numbers. So you win one copy of each. Win one copy. Your original card has 2 matching numbers. So you get 3 and 4. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4. In total, this example power causes you to ultimately have 30 scratch cards. Process all of the original until no more, including how many total scratch cards you end up with. Okay. So I think the key here is that this word instances, we don't actually have to copy all the data of a card. We can think of this as just counting the number of instances in each card. So if I come back to this here, I'm gonna close our test. So we can add a new field here. We'll call this instances, use size. So by default, there's 1 instance of each card. And I'm gonna draw this. So I'm gonna do like dx. So this is card instances, card D. And then we'll say D matches. So our matches will become this. So we no longer have a score. So if it's a match, we'll just say card dot matches plus equals 1. We're not going to append it to the answer. So, see this one 5, card 6, 2 matches, 9 matches. And let me just tell you what, I'll do 1, 2, 3, 4. Those numbers are too close together. Okay. So once we've figured out how many matches of cards there are, we can say, okay, if card dot matches is greater than 0, we can basically say it's going to create a copy of cards from So, I don't know, so we're going to go from 0 to card.matches, right? We need this index. We need this index. So this will be 0, this will be card, this will be the card index. So const the next card index is going to be equal to the card index plus I. But if we're counting from 0, so we need to add 1. So it's always the next card after the current card. And then we will just say solution.cards next card I instances plus equals 1. Now we know once we've got to a card, because it only ever copies cards further on, we know the card we're at can never gain more copies. So once we're at that card, we can start to add that to the solution. So we can say solution.answer plus equal card.instances, right? Because we know this card will never gain any more instances. We only ever increment the instances of cards, future cards. I think that's correct. I'm going to try this with our test data again. And I would like to slow this down. And I would like to see what it said about the test data. So it's expecting 30 from the test data. Let's see if that is correct. We've got this is expecting an I32, which you can guess from a U size quite easily. I don't know why that can't be U size. So right now we're getting 15. In fact, can we just not use time for now? Because we can see them all on screen anyway. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But the example, so where are we going wrong with this? So card 1 has 4 matching numbers, so you win a copy of the next 4 cards, 2, 3, 4 and 5. So we should get an instance, an extra instance of those. Your original card 2 has 2 matching numbers, so you win copy of 3 and 4. We need to multiply the number of matches by the number of instances, I'm pretty sure. So we actually need to say card that matches is incremented by card.instances. Because each of those instances is also got the exact same matching number. So now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. We've got 19. And what did it say? Do I then need to do the same thing here where the number of instances also needs to be multiplied by the number of card instances? I think so. But then that's going to give me too much, is it? So there's only one instance of this and 4 matches. So the next 4 cards get a bonus instance. And then this card has 4 matches. No, this card should only have 2 matches. Why is that saying 4 matches? No. This should be card that matches. But we need to increment the instances of future cards by the number of instances. See, this is giving me 30. I think this makes more sense. Yeah, 2 matches, 1 match. But this has 8 instances of card 4. So we should get 8 copies of card 5. Even though there's only 1 match. If there was 2 matches of card 4, we'd get 8 times 2. We'd get 16 copies added to card 5. And the answer is 30. I'm gonna push this offset, and this I'm going to make smaller. It can probably be 300. And now we can go ahead and put back in day 4. And I'm going to get rid of this expected answer. We can put in back in time. So there's the answer, 5833065. And we're seeing how quickly these numbers can iterate. But then it sort of resets as soon as you get to anything with 0 matches, which is kind of cool. Or it rapidly depletes if you get a zero match card. Cool. So the answer we got, let me just make a note of this. We got this, and we were expecting this, and we got it correct. And there we go. That is day 4 complete. So the only day left where I've already sort of done this before Christmas was day 5. I did that without recording. And then once we're back to day 6, I'm pretty much back in the dark again. It's interesting how I still find these quite challenging, even though I've done them before. They're quite nice puzzles. I'll go ahead and update this so it's also available on GitHub, and I'll see you for the next episode. Thank you very much. Bye.